Good morning, one and all. I am N. Jagdish and I am here to give you a seminar on D&D, and my topic is about JK flip-flop. Conversion and applications. So, flip-flop is a circuit that maintains a state until directed by input to change the state. A basic flip-flop can be constructed using 4 NAND gates or 4 NOR gates. These flip-flops are classified into 4 types, and they are RS flip-flop, JK flip-flop, D flip-flop and T flip-flop. Let's look into the logic diagram and truth tables of the different types of flip-flops. First, our main topic is JK flip-flop, and that is our seminar topic. So JK flip-flop, this is the circuit diagram of this JK flip-flop. In this JK flip-flop, we can easily find out that there are 4 NAND gates, and we can see that this second NAND gate output is connected to the 4th NAND gate and 4th NAND gate input, and as well as the 4th NAND gate output is connected to the second NAND gate output, and the circuit diagram shows the JK, and this is the clock, and the outputs are Q and Q bar. We also take Qn and Qn bar, and so this is the characteristic table, or we can also call as truth table. So first, inputs J and K. First we also take that clock when we apply 0, there is no change in the outputs, so they are Qn, and if we take any input 0, it gives 0, and if we give any input 1, and the output will be also 1. So when we apply clock 1, these all outputs will be appeared here. So when clock is 1, this table is formed. So here we can see that input J is 0 and output K is also 0. Here we have 4 conditions. What they are: 0 0, 0 1, 1 0 and 1 1. Here we take the inputs 0 0, 0 1, 1 0 1 1, and Qn we take once we take Q value as 1, and otherwise, and in another case we take Qn in 0 condition. So we take 2 conditions. What are Q value is 0 and Q value is 1. So in this both conditions we can apply this. JK conditions are 4, so here we have Qn conditions 2, so there are 8 total possibilities that we occur here. First we take 0 0 0 0 condition. First we take 0 in Qn side. First if we take 0 0 and JK here, and Q value is 0, so the circuit is going on, and the circuit gives the output as 0, because if we take 0 Q here, this is output 0 is connected to input of this 4th NAND gate Qn bar, and the Qn bar gives result as 0, as well as 0 0, and Qn we take another condition as 1. So here we take Qn is 1. So if we take Qn is 1 here J is 0 and K is 0, so both are zeros, and Q is 1. So the process undergoes, and the outcome will give the Qn plus 1 condition and gives the answer as 1. So this is the condition for Qn plus 1. So the output will gives the answer as 0. For if we take input as 0 Qn, it gives the output as 0, and same Qn is 1, it gives the output what 1. So in the same way we try to find out 0 1 condition for 0 1, and we continue for 1 0 1 1 with the same inputs 0 and 1. So this is the characteristic table. So let's move on to the characteristic equation for JK flip-flop. We get Qn plus 1 equal to J Qn bar plus K bar Qn. So here this is the characteristic table we occurred. So this characteristic equation for JK flip-flop is again I will explain to you after, because they are written by me. So we have to apply first K mapping, so I will explain you later. So first, what do you mean by a clock? What do you mean by clock means? A latch is a basic memory device to store one bit of information. It is sequential electronic circuit that has no clock input and changes output stage only in response to data input. So a flip-flop is a clock controlled memory device. It differs from a latch in that it has a control signal clock input. So here we can understand that clock is what? Clock is a flip-flop controlled memory device. Clock is a controlled memory device. It stores the input state and output the stored states only in response to the clock signal. If a flip-flop accepts its inputs at L and H to L, and vice versa, both are possible transition. It is a positive edge triggered. We all know that positive edge triggered, a negative edge trigger, and there is another edge triggered. So we have those types. If a flip-flop is used to store one bit of information by connecting several flip-flops together, they may store data that can represent the state of the sequencer, the value of counter, an ASCII character, the computer's memory, or any other piece of information. Here what is the work done by flip-flop is, flip-flop is a device that takes out inputs as zeros and ones and it converts it into ASCII characters. As we all know that the ASCII characters of any of all the alphabets, for A we have 65, B 66, and so on up to some extent. So these are the ASCII characters in the computer memory. So this all work is done by the flip-flops. We have some matter about D flip-flop. So we see it later. Here is my seminar topic and this is my assignment. So JK flip-flop. So the main JK flip-flop is also called as universal flip-flop. JK flip-flop, here we have the diagram. You can see that JK flip-flop. So the same circuit diagram, the device which is here JK flip-flop, the whole device is the circuit main diagram is here, and this is indicated as a normal diagram. So this is the circuit diagram as I explained you above. This is the circuit diagram as a written, and this is the truth table. So here we have this characteristics table. As I said that if a clock is 00, we have the no change in the output. So whereas if you take the clock has both conditions, positive edge trigger, negative edge trigger. 0 we consider as no change, and upward condition we take positive edge trigger. So let us consider positive edge trigger. So in that condition we take all those 8 possibilities as I said above. So in that condition we get, first we consider for 00 condition. 00 condition we get Qn. So in the 01 condition we get reset, and in another condition 10 we get set, and in another condition 11 we get Qn bar. So here we can observe that if a clock is 0, no change for the first two outcomes, and for the next if we apply positive edge trigger we get first 00 condition as Qn, and 01 condition as reset, and 10 condition as set, and 11 condition as Qn bar. So yes, JK flip-flop is a universal flip-flop. It has a drawback that the Qn bar is a toggle. As we all know that the toggle means if the input is Qn, the output is Qn bar. So this is the toggle for this is the drawback for the JK flip-flop. So we have to change this toggle. So as it is a JK flip-flop and it is also a universal flip-flop, so we have to remove this toggle by applying some conditions. I will explain you later. So this is the excitation table. Excitation table is occurred from this characteristic table only. First see this Qn plus 1. So in these both conditions we take Qn plus 1 0. First we took 00 01 10 11. So Qn plus 1. Qn plus 1 we take 00 condition. We have two here 00. So we have two conditions. In those two conditions you can see that JK opposite to the both the 00 conditions we take JK we have 00 here when we consider this, and next 0 0 we get 0 1. So here is the change in k value. So k value we take as don't care, and we apply 0 don't care, as well as 0 1 0 1 condition. We have 0 1 condition in both sides. What 0 1 condition means, here we get 0 1 condition, and another condition we get here 0 1 condition. So in those both conditions we can apply that. So there is a change in k output, so we wrote as 1 and not gate. In the same way, 1 0 1 0 we have both two conditions. In those both two conditions we have first jk is changing, so 0 1 0 1 changing, so we take that as don't care, and the output is 1. So the result is j is not gate, j is don't care, and k is 1. So same as well as 1 1 1 1 condition we have both here 1 1 and 1 1. So in those both the 1 1s, so the change in the j we have the change in j, so j have changes. So in those j changes we take 0 1, so we take don't care first, don't care and 0. So this is the excitation table. This excitation table plays a vital role in any of those after this. So this is the excitation table important to us. So k-map, as I said that k-map characteristic table gives the result as qn plus 1 equal to k bar qn plus j qn bar. So this is occurred from this table only. We take j k qn, j k qn. If we take those three j k qn's and we apply some k-map, k-map means we have to draw the table of j k qn and take those conditions as 0 1 0 0 0 1 1 1 1 0. So we apply k-map and we get the result as characteristic value, and the output is qn plus 1 equal to k bar qn plus j qn bar. So we completed jk flip flop. So the main condition we have to occur here is the timing graph. Timing graph plays a vital role here. So first take the timing graph. As we took here the positive edge trigger, we took the positive edge triggered timing graph. In that, roughly we can take a graph like this and another graph like this. In those two conditions, we apply the outcome. The outcome is occurred by, if the condition is 1 1 condition means it changes from 0 to 1 or either from 1 to 0. So here the changes will occur here. So this is the change now. So this timing graph is like that. Here also we have another condition. So here I wrote, see, if the condition is 1 1, there is a change in either 0. If it is 0 up to now, then it changes for 1 in the next stage. So we occur here. If our condition is 1 1, the output is 0 or 1. So here I already said that there is a drawback here which is called toggle. So in order to get the toggle, toggle is to be drawback for this universal JK flip flop. So in order to get rid of that toggle, we take master slave condition. This is the best condition. These are also two. There are t by 2 less than delay condition and exit condition, but master slave condition is the best condition for the toggle reduction process. So here this is the master slave, and I wrote here, see, master slave and here slave. So these both are interlinked with each other with a j equal to 1, k equal to 1, and outputs qs and qs bar. So here we take two jk flip flops and one input of jk is, we also know that jk flip flop main circuit diagram, it is the same circuit diagram, but this clock is connected to an AND gate, and this output of this clock is converted to input of the second clock signal. So in this way we can conclude that master slave is the best reduction process of getting toggle for the JK flip flop. So here we can get the toggle we get read, and the output is cleared, and output is get cleared. So this is the circuit diagram, and this is the diagram. So in this way we can conclude that the drawback of this toggle, which it means, toggle means qn is input and the output is qn bar. So as it is a universal flip flop, we shouldn't get a toggle. So in order to get the toggle, we apply this master slave is what the jk is connect is multiplied, it is multiplied into 2, means we take two jk flip flops and we interlink those two with the help of another NAND gate and connect clock signal another way from the same clock signal. So here we can have this output not to be a toggle. So this is the condition for the JK flip flop to be master slaved. So this condition is very much important for a universal flip flop. So this master slaves plays a vital role in those JK flip flops. So JK flip flop is a universal flip flop. So and that's all for it. Completed Simna. Thank you.